Honestly, guys, I might have gone too far this time. What have I done? Well, I was driving home the other night and I was listening to the radio and this song comes on. It's this 1972 Steelers Wheel Stuck in the Middle with You. And I was listening to this song. Recently, I've been doing job interviews, all right, and I've been revising my data structures and algorithms. And one of the lyrics in this song is clowns to the left of me, jokers to the right, here I am stuck in the middle with you. And I had the stupidest realization in the world, which is this condition here actually forms a perfect monotonic condition for us to perform binary search on. Okay, monotonic simply means that data in an array, so take an array, data is going in one direction only. You've probably seen binary search applied to sorted arrays before, where the numbers are in ascending or descending order. That is in of itself a monotonic condition. So the direction of the numbers is only going one way. And that's all you need to perform binary search. So the fact that there will always be a clown to the left of him, there will always be a joker to the right, and here he is stuck in the middle, that means that we can perform binary search on that because there will always, like on this side, there's always clowns, on this side, there's always jokers, right? And then here he is in the middle. So we can binary search to find where he is. I've written a C program to demo this, because of course I have. So what do we have here? Well, if you think about what our demo program is going to have to do, it's first going to have to generate an array that satisfies this condition. So what we're looking to do is generate an array, in this case of this enum type that I've defined here, where in this array, there will always be clowns to the left, there will always be jokers to the right, and then there's this person stuck in the middle. So our enum has 4 possibilities. There's clown to the left, joker to the right, here I am, and then there's you, because he's stuck in the middle with you. That's the whole point of the song lyric, so we got to chuck that in there. I'm representing these by emojis. Yeah, go cry about it in the comments. But we have a clown here, a joker here, here's our little guy, and then here's you. So these are the 4 things that can be in our array. And we've got this generator function here. And the point of this generator function is, if I go ahead and show you, it's going to generate an array like this. So our guy is right here in the middle. This is like 50 people, right? So there are clowns to the left of him, jokers to the right. Here he is stuck in the middle with you. And then our program is going to go ahead and search that array and find out where he is. So all the generator function does is pretty simple. You pick a random number of jokers, which is going to be between the length. So we take in a length after we malloc an array, like a base array. We're going to find a random number of jokers with the max range being length -2, because of course we need to include our little characters. So it's going to be -2. Then our number of clowns is the leftovers from that. And we just go ahead and fill. So this is going to fill the left-hand side with clowns. Then we've got this +2 plus I, and that's going to fill the right-hand side with jokers. And then we chuck ourselves in here at the middle. So this is where it gets really fun. Let's go ahead and look at the binary search. I've just got this helper function here that prints things out. It's not really worth going over. Let's look at binary search. So binary search, you've probably seen this kind of like function pseudocode before. Basically what we're going to do is we fix our lower bound at 0, our upper bound at length -1, and we're going to calculate the midpoint. That's the whole point of binary search. We divide and conquer, we take half, and we divide by half every time. That's what gives it its time complexity. So what we're going to do here is find the midpoint, right? Ignore this, this is just for statistics. If you actually look at the conditions that modify our bounds, we check the index. If it's here I am, then of course we're just going to straight away return that. If it's you, then we're going to return that -1, because if you remember from our board, like we're always placing his girlfriend to the right of him, right? So his position will be the girlfriend -1 naturally by our generated condition. If it's a clown to the left of him, because remember there are only clowns to the left of him, then the lower bound is going to jump up to become the midpoint +1. Otherwise, if it's a joker, the upper bound is going to jump back and become the midpoint -1. And that's pretty much all it does. So what I've done is it actually will print it out in real time. So you can see this magnifying glass is where the program is searching for, and you can see there it finds him. So you can see this in real time. I've got it to print out the steps as well. So it starts here in the middle. This is like 50 people. So it starts in the middle, then it goes up by 1. It notices that it's back here, it notices it's a clown, right? So that means our guy has to be in this next half. It goes in half again. It realizes it's a joker. So this guy has to be in this section right here. It's going to take the midpoint again. It's another joker. So he's got to be in this section right here. It goes back. It's another joker. So he's got to be here. And then, of course, on the last step, it finds where his position is. And, of course, we can see stuck in the middle with you at index 25. And it only took it 5 steps. So now I'm going to use this song lyric to demonstrate to you guys why binary search is one of the most efficient algorithms in computer science. So let's go ahead and say there are 1,000 million people. He's got so many people and he's stuck in the middle of all of them and they're all clowns and jokers. How long do you think it's going to take our computer to find out where he's stuck in the middle? Let's find out. This is in real time. It only took 28 steps. So he's at whatever index this is, and he's stuck in the middle with you at this, and it only took the computer 28 steps. So there you go. That's absolutely incredible. And by the way, if you're wondering why the board didn't show up, I disable it for lengths over 1,000 for obvious reasons. But yeah, anyway, that is why binary search is one of the most efficient algorithms in computer science, demonstrated with the lyrics to the 1972 Steelers Wheel song, Stuck in the Middle with You. Thanks, guys. Have a good one.